equilibrium state or a steady state we can. So n is equal to I minus q. And from the above matrix reveals if we can't take the first year dropout, then we can increase the graduate of our first students. This is real-time applications that we have, and each and every data is collected from UK-based colleges. So tangent matrix states transition diagrams. The matrix describing Markov chain is called a transition matrix. The transition diagram is to describe Markov chain. It shows the transition between different states, just like this. Here, two states is hot and cold. So one is this RDB is moving the same places in 0.2 probability and 0.8, 0.6, and 0.4. From this one, we can form this matrix: hot, and cold, hot, and cold forms. And initial distributions 0.8 and 0.2. So using this one, we can find out the long term also. Pi p is equal to pi. So pi is the initial distributions, p is the given matrix. So after some times, after n tends to infinity, we can get some part is a stationary part. So tangent property matrix must list all the possible states in the state spaces. It's a square matrix because xt plus 1 and xt both take values in the same state space. So rows p should be each sum is 1. So another part of this Markov model is a hidden Markov model. Hidden Markov model are a class of probabilistic graphical model, and it is very useful to unsupervised learning data sciences that allow us to predict a sequence of a known variable from a set of observed variables. A simple example of hidden Markov model is predicting weather based on the type of clothes that someone wears. And a hidden Markov model can be viewed as a base that unrolled through time with the observations made at a sequence of time stepping being used to predict these steps and hidden states. So to make this point clear, let's consider the scenario of the weather and the hidden variables can be hot, mild, or cold, and the observed variable or type of clothing worn. There are represent transition from the hidden states to another. Hidden states are from the hidden states to an observed variable. Notice that the two of the Markov assumptions, each state one depends on the previous states and not on any other previous states. So just like this, these cases, one is hot and warm, mild and cold. Weather depends upon the weather. Then observation is clothing just like this previous day and present day and next day. From this experiment, it is a probabilistic model that allows us to compute the joint probability of a set of hidden states given a set of observed states. The hidden states are also referred to as latent states. Once we know the joint probability of a sequence of hidden states, we determine the best possible sequences. That is a sequence with the highest probability and choose that sequence as the best sequence of the hidden states. Generally, the terms states are used to refer the hidden states. One is a transient state, an emission, and initial state informations. The initial state informations is the initial probability of transition of the hidden state. This can also be looked at as the probability. Emission is the probability of transition to an observed state conditions on the hidden state. And transition, the probability of transition to a new state conditions in the present state. Just like this. So it is a prior forms hot and mild and cold. This probability is 0.6, 0.3, and 0.1. So transition hot to hot 6.3. These ones are mild and cold. The emission probability, so varying from the observation. So observation, casual viewer, semi-casual viewer, and so in this type of experiments, from the observation, we can find out the sequences. So here we are the casual viewer, semi-casual viewer, and we the pure. Then from this data,